Okay, thank you all very much for coming. What we're going to talk about today is writing a foreign data wrapper in PostgreSQL. First of all, my name is Christophe Pettus. I am the CEO and lead consultant of a small Postgres consultancy called PGX. We're based out in California, in the Bay Area of California. If you'd like to say hi after this, we have a booth. Please come over and do so. Okay, so we're going to say FDW for the rest of the talk because saying foreign data wrapper over and over again gets tedious. It was a feature introduced in 9.1, and it's a method for getting data from other data sources into PostgreSQL. So it could be a different database, it could be a flat file, it could be the National Weather Service weather feed. It can be any data source you want that you want to include inside your Postgres database. So before we get into FDWs proper, I want to talk about what a foreign table is. So a foreign table, which is a construct in Postgres, there's a create foreign table command, is like a view. It has a schema. You query it like any table. It looks like any table. It can have constraints, but there's no local data associated with it, same as a non-materialized view. It's just a schema. It represents a data source on a different system. And the planner, the executor, and the FDW all work together to get this data back into Postgres. So you could mount an Oracle table as a local foreign table, query it, and then it's up to all of the Postgres machinery to turn that into a thing that gets data out of the Oracle database and back into your database. And again, as long as you can express it as a relational table, it doesn't matter what the actual data source is like. It doesn't have to be a separate database. It can be anything that the FDW can transform into something that kind of looks like a table. So each foreign table has a server associated with it. There's a create server command in Postgres, and that represents the remote data source. A single server can have any number of foreign tables. What a server really just is a bunch of options. It doesn't really there's not like semantics associated inside of Postgres with a server, but the kind of options you would have with it is like, for example, the access path to a remote database, or if it's a flat file, where on the file system that flat file lives, or things like that. Postgres core doesn't do anything with it. But the server is associated with a foreign data wrapper, which is where this appears in it. So each server is associated with a particular foreign data wrapper. And since each table is associated with a server, each foreign table is associated with an FDW. And so right now, FDWs are written in C. So you do have to warm up your C experience to write a foreign data wrapper. There is one alternative that I'll discuss right near the end, but it's a little questionable. So be prepared to write some C. There's moves of front to have more modern languages available like Rust, not in the core project, but elsewhere. But right now, C is where it's at. So what does the FDW actually do? It's responsible for handling the queries on the foreign table. So when the client issues a query that touches a foreign table, a lot of things happen, but ultimately the foreign data wrapper gets called to say, I'd like some data this way. It doesn't get the SQL, and this is very important. It does not get the raw SQL of the query at any point. The FDW never sees that. What it gets is internal planner data structures. So you have to get a little familiar with them. They're pretty well documented, and the good news is you don't really have to know much about them in a very simple case, unless you're planning to implement a foreign data wrapper with extensive functionality that can do things like joins on the remote server and all that. The amount you actually have to know about these structures is pretty low. So what happens is it gets the parse version of the query and tells the planner, okay, I think I can execute this plan in the following, what you want in the following ways. Those are called plans. The planner picks one for it and says, okay, do this one. I like that one. It executes it and it returns the tuples back to the executor. So it kind of looks like this. Here's your foreign data wrapper. The planner says, okay, here's a parse query. Give me some paths. What a path is in Postgres is a potential way of executing a query. How many have run an explain analyze or something similar on a Postgres query? Okay. what you're seeing, what happens there is the query is handed to the planner and it tries a lot of paths. You don't see that. You never actually see the paths it didn't pick. But it tries to find the lowest cost path, that cost, number, dot, dot, number. And then the one you actually see and explain and analyze is the one it picked. And that's what this process is it the foreign data wrapper hands back a bunch of potential paths and says, I could do it this way, or I could do it this way, or I could do it this way. The executor picks one and passes it in and says, okay, I like that one, please do that one. And again, you never see the SQL. If you need SQL for this query, it's up to you to regenerate it. And it's kind of a lot of work. You can look in contrib Postgres dparse but one of the so that's the bad news. The good news is you don't have to worry about any part of the query except your foreign table. It's already been kind of, so suppose you have this wacky query that has like 12 joins, and one of the joins is on a subselect, and that subselect goes to a common table expression, and the common table expression has a select on your foreign data wrapper. You don't see any of that other stuff. You never have to touch it. You only have to execute that select. So that's the good news for one of these. If you're writing these, you're writing them in C, which means you have to allocate memory. Well, that's life in terms of C. Postgres, if you're not familiar with it, has a very sophisticated memory allocation system, which is called generically memory context. It has its own version. If you're familiar with the malloc function, which grabs a bunch of memory, a bunch of heap memory, it has a version called palloc, or a bunch of utility functions that call them. The nice part about this is that when you're running inside a foreign data wrapper, you're running inside of a memory context that's specific to the query you're executing. And when that query finishes, Postgres just throws away the whole memory context. So memory leak problem solved, more or less. You can still leak memory, but you have to work a little bit harder at it. Do release stuff you don't need anymore, just as a matter of hygiene. Now, occasionally in a foreign data wrapper, you're going to have to allocate stuff. Now my throat fails. There we go. We're going to have to allocate stuff that lasts between queries. For example, suppose you're writing an Oracle foreign data wrapper. Somebody uses Oracle, I guess. And you have a connection to the remote Oracle system. You don't want to open and close a connection with every query. You kind of want to keep it open because that'll be a lot more efficient. You need a place to store that. So you'll need to store it in global memory. You can do that, but just remember, first of all, make sure it's properly reentrant. Right now, the reality is you don't have to worry about it because each backend is single threaded, so there's only going to be one execution path using your foreign data wrapper at any one time, but don't count on that. So just be sure about that. Okay. One of the things that's really cool about writing stuff in Postgres is it gives you a lot of help. One of the problems in almost any C function, C does it not having exceptions or any other built-in error handling mechanism except, segvault, is how to handle errors and kind of get out of this. Postgres has a built-in function called elog. One of the nice things about anytime you see an error being written into the Postgres logs, somewhere elog was involved to generate that error. The nice part about it is if you're running along and encounter a situation, you have to stop. Bad syntax, they're trying to access a column that doesn't exist on the other system, something like that. You can just run elog with an error status and your execution ends at that point. So you don't have these complicated returning status codes and all this nonsense. You can also do debug logging. There's a debug 1 through 5 error levels, which are normally not turned on in Postgres in most installations. So you can turn those on and generate reams of your own debugging output. So a word about datum. So if you're not familiar with Postgres internals, everything that you think of as a column value in Postgres is described as a single type called datum. C is not an object-oriented language. Postgres is not really written in an object-oriented kind of way. But you can think of this as, if you're familiar with object-oriented programming, the base class for int and float and text and user-defined types and JSON-B and everything is all represented by this one type. Datum, if it's less than the size of a pointer, if the value is less than or equal to the size of a pointer, 64 bits in most cases, it just stuffs it directly inside of datum because that's how big a datum is. Otherwise, it's a pointer to the real thing. So for example, if it's an int, it's inside datum. If it's a text field, it points out to the text field someplace else. It's defined in Postgres.h. Take a look at it. There are also a bunch of built-in routines for managing datums. Like you have a datum and you want a C string from it. There's a function called to do that. So use all of that stuff. Don't try and decode what's inside of a datum. One of the catches about datum is that makes it really not object-oriented is there's nothing in datum that says what type it is. It's just a pattern of bits. So someplace else, like you have an array of columns, you'll also need an array of types to say what type it is. So you have to know what type it is. So it's not really like an object-oriented object. It's up to the client to create these foreign tables. So they issue a create foreign table command. It's just like any other table. There's no restriction on what they can create. So they could create something that's completely wacky and has nothing to do with your foreign data wrapper. For example, let's say you're implementing a weather service temperature, and they're just two and what this does is it takes a city name and gives you the temperature back. Okay, that's all it does. So you would probably represent this as a 2-column table, city name, temperature. So then, but a user comes along and says, okay, I'm going to create a table that's going to have a JSON-B column and it's going to have a text column, and I have this user-defined type I'm going to add to and all these things. It's up to the foreign data wrapper to stop you from doing that. There's a validator function you can write, it is optional, that can look inside of that statement and say, wrong, and throw an error. If you can possibly do that, because otherwise you can raise the error at runtime, but it's never great to raise an error at runtime that you could have raised at table creation time. Has anyone here ever written a Postgres extension? Okay. It's not like, the foreign data wrapper is similar to, but not exactly like a for extension. It's not created using create extension, create foreign data wrapper. It defines a function that points to all its other functions. This is very much standard Postgres extension style. You actually create that function in the database using create function rather than create extension. And then create foreign wrapper is used to run that function. It looks kind of like this. Usually this is all packaged up inside of the control file that creates these things, or indirectly called by the control file. So you create the handler, it returns this magic type FDW handler. You create a validator, which returns nothing. This is the path name to the dynamic library, .so, DLL, whatever, depending on your platform. And then you create the foreign data wrapper saying, okay, this function is my handler, this function is my validator. So that's how you actually install a foreign data wrapper. Okay, now it's time for the mind-numbing pile of C code. This is kind of the top of each file. I mean, it doesn't literally have to be the top, but you'll find a handler that returns datum, and you point at all of your real functions. There are lots of foreign data wrapper functions. It goes way down. I'm only going to do the ones you kind of have to do plus 3 optional ones. So you have to have the ones that are not faded out, and these are optional. You can just leave them at nil, and Postgres will never call them. But this is the minimum you have to do. So when your foreign data wrapper is sitting there and needs to run, it gets called. The functions get called in this order. First, get foreign rel side, get foreign paths. These get called once per query. Then iterate foreign scan. This is where you're actually returning data. I'm going to talk about all these, so don't worry about this. You might get a call by rescan foreign type and foreign scan. So the functions and these are all things you write, and they'll get called in this order. Once per query, once per. Okay. So let's walk through them all and say kind of what they're supposed to do. Get foreign rel size. This is the first thing that's ever called in processing query, and this may be the first time your foreign data wrapper ever gets called by anything. So if you need to initialize global context of some kind, you generally put it in here, because this is the first. There's no initialization function on a foreign data wrapper, because reasons. So note that this is per foreign data wrapper query, not per top-level client query. Again, in my example, you could build this giant wacky query that has all sorts of components. It may need to call the foreign data wrapper multiple times to execute each individual foreign data component. Fortunately, the planner takes care of all that for you. Yay. What the planner would like you to do is estimate the size of the foreign relation. One thing to remember is, as far as the planner is concerned, this is a table. It's just like a Postgres table. It has a certain number of rows, it has a certain number of columns, it has data distributed in a certain way. So everything, the way you talk to the planner above it is presenting it like it was a table. So the first thing it'll do is say, okay, so how many rows are in this table, and how many rows do you think are going to come back from the query you're running? And the signature of it looks like this. You get the planner, this planner info, the base rel, and the OID of the foreign table. So what these are is the base of the planner information for this query. So from that, you can look inside of it and say, okay, they're calling this table. You can also get it from there. And these are the predicates I'm going to use. So if there's a where I equals 5, it will appear inside there. Now the good news is, and this is what it expects to get back. The good news is you don't actually have to really do this. You can just throw random stuff in here. Depending on, for example, if it's like one of these remote feeds, you may have no idea how many rows could possibly come back from this query. None. Make something up. Put 100 in here. It'll all still work. So, and generally in very simple foreign data wrappers, that's what happens, is that you give it like vague numbers and put them in. And one of the things that is important is if you need private data, like the connection to the remote database, something like that, that goes in FDW private. So it'll get passed back to you over and over again, but it doesn't do anything with it. It just assumes you know what this is. You can, in fact, you don't have to fill in anything at all. The planner will put in defaults for you if you don't specify anything. They'll be pretty horrible, and if you're writing a foreign data wrapper that's expected to be highly performant and do all sorts of complicated things, you'll want to do a good job here. If you're writing something that's mimicking some random foreign data source that isn't really a relational table or anything like that, you can just accept the defaults. So that returns at some point in the future on that same query. The planner says, okay, that was fun. Now I'm going to call get foreign paths. It's called after get rel size, and this is responsible for planning the query. Like I mentioned before, this is where the planner says, okay, give me all the different ways you could execute this query. Could you do an index scan? Could you do a sequential scan? Could you do a heap map bit scan? Could you do anything? Anything that's available in the Postgres world, you can put in. The reality is you always return a sequential scan, because on most of the semantics of these really are usually, there's really only one thing you can do, which is go out to the foreign table and get a bunch of rows, maybe cutting them down by a where clause. So what you get is more planner info, basically the same thing you saw before. And what you usually do is call create foreign scan path, drop the output into add path, and then you're done. What's nice about this is the machinery can get really complicated. The reality is you don't have to do very much. You generate a single path, and you only generate multiple paths if you think there's really a difference and the planner might be able to make a sensible choice between them. The chance of that being true in your use case is basically 0. For example, even the Postgres foreign data wrapper, which you would think would be like the ultimate in sophistication because it can do joins, it can do all this stuff. If you're not doing a join, which is a special case, and we're not going to talk about how to do push down joins, it just creates a sequential scan. So you're in good company if that's all you do. It kind of looked like this. You call create foreign scan, you kind of pass in the stuff that's required. Just accept that, it's there for reasons. And you pass in the number of rows, startup costs, and all this kind of thing, a bunch of nulls, and you're done. This is completely sufficient for 99% of the use cases for a foreign data wrapper. So that's nice. You can cut and paste a lot of code here. So how much you want, so if people are familiar with explain, analyze, or explain, you've seen those cost numbers. Two floating point numbers separated by a couple dots, right? And the first one is costs are in arbitrary units. They're not in, those units don't mean anything. The only thing they're good for is comparing with each other in the same system. So, you might see for an index scan like 0.005 and 5,000 or some number, which is, the first one is how much it costs to get the first tuple, and the one is how much it costs to get all the tuples. That's what those two numbers mean. You, the foreign data wrapper, are expected to estimate costs on this. Now, it's intellectually interesting and probably good hygiene to do a good job here. The reality is the planner is going to use this information to decide on a particular path. The answer is, how much choice does the planner really have? You're the only foreign data wrapper that supports this data source. It has to use you. So it's not going to pick a different one to execute this. One reason to do this, however, is if your query is inside of a bigger query, and you will want to inform the planner, does it make sense to call this foreign data wrapper multiple times, like call it once for each, for a bunch of rows? Or should it call it just once, get all the results back, and shove it up? Generally, if it's a remote data source, a data source that's not on the same machine, you want these to be big numbers because you want to discourage it from, if you've ever seen the plan of an index scan, there's the one at the top, the one at the bottom. The one at the top, it walks through the set of rows and calls the one on the bottom for each row on the top. You don't want to be that lower node if it's a remote system, because it could be calling you repeatedly to get 5 rows back. So if you have to estimate high, so that it'll be more likely to call the foreign data wrapper once, get all the data back, hold it locally, and memorize it or materialize it. Startup costs, especially on a foreign data wrapper, you should estimate very high, because connection takes a long time in computing standards. Opening a JDBC connection can take like 10 seconds. You don't want to do that on every call. Okay, so foreign paths have been called. You said, here are the paths I like. Here are the paths I could do, usually just one. And the planner then turns around and says, great, I like this path. Please generate a plan from it. It has a lot more stuff associated with it. The good news is a lot more stuff you can generally ignore. So what you generally do is drop make foreign scan, call make foreign scan, a utility function that's provided for you, and return that. It's easy. If you want a good example, you can look at the file _FDW, which is about as simple as a foreign data wrapper can get inside of Postgres. So the T list is the targets the query wants. So if they're selecting a certain number of columns, the T list is which columns they asked for. Scan clauses is what clauses, that is to say the stuff at the where clauses and stuff like that, which of those are going to be evaluated locally? That is to say the local database, the executor will do those for you. The way this is written, basically you're saying, I can't process anywhere clauses, I can't process any restrictions. I'm going to give you everything in the table, and it's up to you to filter it out, which is, for some data sources, the right answer. And you hand the private information back up, and So the good news is, you can almost just cut and paste this into most foreign data wrappers, unless you want to start getting sophisticated and executing where clauses more efficiently. Okay, that's been done. Then you get called with begin foreign scans called, and finally you're getting tuples after all this work. Does any initialization required before the plan begins? For example, this may be where you open the connection to the remote server, or something like that. If you want to allocate a chunk of memory to store the results that come back, it may make sense to do it here. You get past this foreign scan state object, some nodes, and then this little int with a bunch of flags. The foreign scan state is mostly opaque. You really don't have to worry about what's in there. There's one field you have to care about, which is where you put the tuple you get back. eFlags has a bunch of flags. The only one you really need to care about is this one. If you're not familiar with this, in general C convention, you and eFlags with this constant and it'll be true or false. If that's true, you're only doing an explain, because again, this is a normal part of a query. You can say explain and a query that includes a foreign scan, and the explain will actually runs through the planning machinery because it needs to decide what plan it's going to display. This says, yeah, but I'm only kidding. I'm not really asking for any tuples back. So don't do heavy initialization here if you can. The only thing you want to do is if somehow you have like permission checks, like for example, you open the connection to the other side and it fails. It's a good idea to do these here because they know that at explain rather than when they try to run the query. After that is iterate foreign scan. This is where you actually return data back to the executor. So this is what it's all about. It's called repeatedly after begin foreign scan. You hand one tuple back up, and you return null when there's nothing more to return. Kind of very simple. It looks like that. Couldn't be easier. That same opaque foreign scan state that you got called with before, you get called with it again. There's a special place that the executor wants you to put this tuple, which is in the node structure, the field SS, the subfield SS scan tuple slot. We're just going to call that slot. You call this, which basically resets the value of it. Says okay to a null tuple. Slot TTS values is an array of datums, so that's where you put the data. So yay, finally you have a place to put the data. Notice that there's no type information here. It just assumes that you're going to make sure that the type information is right based on the columns that the executor requested. And a null flat arrays. If one of these is true, the corresponding position is null. Pretty easy. And if there is data, you use this exec store virtual tuple slot. I'm not going to go into the extremely tedious difference between a virtual tuple and any other kind of tuple. You almost always, you want a virtual tuple here, trust me on this one. And then you return the value of slot and you're done. And because if you didn't store any data in it, you never called this, it's going to be null, so you get null. Pretty nice. One nice thing is each iteration has its own memory context. So if you allocate a bunch of memory inside of iterate forward scan and return, it all gets cleaned up for you. So there are functions that you use to switch to a higher context. For example, you are keeping track of a number of rows that you've returned or an offset in a file or something like that. And you need to allocate it in here. You can do that. Just remember that you need to switch to a different memory context. There are functions that can do that for you. And be sure to switch back. You have to implement rescan foreign scan. And you may, out of nowhere, get called to say, do that over again, please. And it's up to you to reset any state you have to do and do the foreign scan again. The good news is you don't have to return the exact same set of tuples. It's fine if the set of tuples changes from the ones that returned earlier. That's expected by the executor. It's generally called 0 or 1 times, but it could be called any number of times. So you don't write any code that assumes you'll only get one call. That looks like that. And finally, and foreign scan. You probably saw that one coming. When the executor's done with this, with you executing this query, it calls that. This gives you a chance to clean up anything you have to clean up. You probably don't close a connection here because you may want to reuse it for a future one, but you may want to close, if you're reading from a local file, you may want to close the file here, something like that. The good, one thing to note is this is really your only chance to clean up between subsequent query calls. So take advantage of that to release anything you don't actually need. And it looks like that. So at this point, you're done writing a foreign data wrapper. That was plenty, but you're done. The three I'm going to talk about now, you're not required to implement, but you probably want to. There's explain foreign scan. So remember when we did that, if somebody didn't explain, if you've looked at explain plan, there's like the planner node that says, I'm doing an index only scan, I'm doing this. And then there's some information below it that says, like, might say filters, or might say what key it used, or something like that. You have the opportunity to explain yourself, as it were, to explain what you're going to do in the foreign table scan, and that can be very useful to someone who's running a query on your foreign table. Basically passes in the scan state and return, and you an explain state. You just call explain state with the information you want to add to the explain plan. And by the way, in case you're using fancy Unicode, it's a good idea to have 7-bit ASCII. It's not clear how different encodings would work in this circumstance. There is an analyze foreign scan. If you implement this, you're kind of expected to do the same thing that a real analyze does on a real table. It passes in the relation, the table, you're expected to fill in a function and the number of total pages. You return the Postgres size pages in total pages. You can get the size of a block from block size. It's usually 8K, but they can compile for a different number. So for example, if it was a file, you might take the file size, divide it by block size, and return that as an integer. You return a pointer to a function that will be called repeatedly to get row samples. You can look at the one in the foreign data wrapper for a sample implementation. Honestly, you probably don't need to do this, especially if you're not implementing any where clauses. Because what it's going to do with this is decide, should I push down the where clause? Should I execute it locally? Should I do stuff like that? Don't. And if you're not implementing them, probably not worth the trouble. But if you are implementing a sophisticated one, you can do this. This one, however, is pretty important, which is import foreign schema. So remember I said earlier that no matter what your data source looks like, the user, the client, can create a table that looks like anything and say, this is my foreign table with all these fields that you have no idea how to process and all these wacky types. Import foreign schema is your way around that problem. When you call import foreign schema table, you, the foreign data wrapper, get an opportunity to say, here's the create statement for this table. Please use this instead. So it's so for example, in the temperature service question, you might return text and float as the two values. And that way you have this doesn't prevent the user from creating a wacky table, but it means they don't have to write the create statement themselves and do something bad. Pretty straightforward. It says import foreign schema and the server. What you get is the remote schema if there's a schema qualification on it, or none if there isn't. And you return a list of actual textual DDL statements. You literally build the create statement itself, you know, get to use all the formatting stuff and things like that. And it returns a list of the actual textual DDL statements. So this is your chance to return real create statements. You can say create, you can say create if not exists, or you can say drop plus create. If, for example, if somebody runs create foreign schema twice, and you just use a bare create statement, they're going to get a bunch of errors because it tries to recreate all the stuff twice, and that's a little unfriendly. You probably, however, highly recommended do not issue drop statements unless you put an option on your import foreign schema that says, yes, dropping is okay, because otherwise you could be destroying information that unnecessarily. Okay, speaking of options, if you look at all the various create statements, there's options in parentheses at the end of it. Create foreign data wrapper, create server, create foreign table, an individual column within a foreign table, and import schema can all have options. They're entirely defined by you. You can put whatever you want in there, the semantics, the syntax, everything is up to you. When any of these objects are created, the validator function is called to say, are these okay? It's basically, it either returns or it calls an error and thus doesn't return. If it isn't, you don't have to write a validator function, in which case it'll just accept any old garbage on the options and hope it's all okay. Again, as a matter of sort of being a good citizen, if you can implement a validator function, not too much work, and error out if somebody specifies a completely random option you have no idea to handle, that's preferable because it's kind of, first, it's unfriendly to accept an option and not that is completely meaningless for you because the user could have made a typo and be sitting there wondering why this isn't working. And it's unfriendly also for the user to go through all the creation, do all this, set up the whole thing, run a create statement, run their first statement and get an error because they made a mistake way back up here. So implement the validator function. Something we didn't talk about is, if you want to get more sophisticated with FDW, build the simple one first, don't leap into this stuff. You can, the foreign data wrapper can be a lot more sophisticated. For example, all these things you can say, I'm going to do these for you. So for example, if you're executing against a foreign database, you can advertise in your foreign data wrapper, I can do joins remotely. And the planner will dutifully kind of reorganize things so if there's a join between two foreign tables on the same server, it'll put them together and pass it in and say, okay, you said you can, and then it's up to you to figure out how to execute that. It's a pretty sophisticated piece of code. You can look at the Postgres foreign data wrapper for examples. You can also execute order by, group by, and aggregation there. So for example, you can do if they do a sum, you can do it over in the foreign server and pass just the result back. Work up to this. But the Postgres FDW is a good place to look for how to actually build that stuff. Okay, almost done. So I promised that that with all of this, there was an easier way to write it. There is a tool out there called Multicorn. You can look for it at multicorn.org. It lets you write FDWs in Python and a lot of all of this, planner nodes and blah, blah, blah. It just handles all that for you. It's really neat, and there are a lot of things written to use it. The reason I'm a little bit hesitant about it is I'm not sure of its maintenance status because the last reference version that it said that was pushed for changes was Postgres 13. But if you're writing a very, very simple, the very, very simple foreign data wrapper, you might want to take a look at this first, now that you know how a foreign data wrapper works. Okay, and so have fun. If you could express the data as a table, you can write a foreign data wrapper for it. There are tons of foreign data wrappers out there. Note that the Postgres wiki is not always 100% current, so be careful about that. The main reason I like foreign data wrappers actually is if you've wanted to get into writing Postgres internals code, but it looks really intimidating, a foreign data wrapper is actually a good place to start. You learn a lot about the internals, but in kind of a simplified, handheld way. I realize for people unfamiliar with C, simple may not be the first thing on your mind through all this, but compared to much more sophisticated extensions and things like this, it's pretty straightforward. And it gets you familiar with how the planner works and how the executor works, all this kind of thing. So it's a good, toe in the water for this. And one more thing, because I've had to deal with this a lot, test your foreign data wrapper very thoroughly. You have to have a sensible test suite for it. And I realize if you're talking to an Oracle database, this means you have to have an Oracle database out there. still do it. Because one of the things, and having said this is easy and you should, this is fun and you should just do it, one word of caution. You're inside the Postgres backend here. You're a piece of C code running the Postgres backend. There are no guardrails to keep you from trashing memory except the quality of your code. So it's not probable that you will do this, because if you write in a very stylized way, you'll generally stay nice and right down the middle. But you can bring down the server, because if one backend seg faults, all of Postgres restarts. You probably don't want this happening in production. So this is a good place if you have a test-oriented development or some other testing philosophy. This is a good place to be very thorough with it. And that's the talk. Thank you very much. This is my my tech blog, so feel free to check it out, thebuild.com. And any questions? Sir.
What kind of guarantees does FDW give you in terms of consistency? Because, you know, for example, what's the snapshot that you're talking is going to?
Well, every one of these is going to be running inside a single transaction. So I didn't go into, foreign data wrappers can modify data on remote servers. You do receive notifications, for example, if the transaction rolls back to say, you know that updates, please don't undo them because the transaction rolled back. So so on reads, basically, you don't have to do anything special about transactionality. If you implement one that writes, you do have to decide how you're going to handle these signals from Postgres saying, the transaction you just ran, sorry about that, time to roll it back, whether it's even reasonable to roll it back, you know, in that case. A lot of modifying foreign data wrappers don't implement rollback, you know, and just live with the fact that they're not fully transactional, yeah. Like a lot of them that run to things like queuing mechanisms like Redis, because there's no practical way to roll back something that you've done there, so that you just don't. And you put big red mark on the for data wrapper saying warning, rollback does not delete the entry you just entered. Sir.
Were you there during the lightning talks?
I was not.
Oh, okay. Rats. So Jonathan Katz mentioned vectors is a more and more popular data type for machine learning, and he was talking about how if your vector exceeds 8K, then it's going to be in a post table. And I was curious if you think you could beat post performance by writing a vector FDW, say to files locally on the disk.
A little bit of a how long is a piece of string question. I mean, the answer is, well, if you have some miracle breakthrough in the algorithm and it's, you know, blindingly fast, then yes, it'll probably be faster. The foreign data wrappers have a fair amount of overhead associated with them. So, you know, I'm not going to say performance is unimportant on them. Of course, performance is always important on everything. However, they're not going to be blindingly fast on a lot of data access. If it might make more sense to implement types like that as extensions, because then you're kind of everything's on you to make the stuff go fast. You know, you're just processing structures in memory with C. Extensions I always get a little nervous if extension does something significant outside the server besides just logging and things like that. So if it's like communicating with a remote resource, then that remote resource can potentially not be there. That always makes me nervous. But of course, foreign data wrappers, same thing can happen. You know, you could try to connect to a server that's not there. So if I'm doing it as a quick implementation to see how this would work, foreign data wrapper might make sense. If I wanted to get the absolute most blazing performance possible from a vector DB type, I assume this is a type you like create with create type and, you know, use as a table and use in tables and everything. You'll have to at least define the type if you want to use that type in a table, because foreign data wrappers just use the types that exist in the system. They're not the mechanism for defining your own type. You just create a separate extension for that. And did that even come close to answering your question?
Yeah, I think so. I mean, it could just be a float array, right?
Yeah, I mean, you know, you might want to make it. You won't want to make a special type just to advertise could even be a domain at that point, just to advertise, by the way, this is a special magical vector, not a boring old array of floats, you know, which that's a pretty common mechanism. Postgres does that in a lot of places, where it takes a really boring normal type and wraps it up inside a type def to say, by the way, I mean this, you know, it's like, you know, slots just a pointer. Anything else? Okay. Completely overwhelmed? Yeah, it's complicated, but this talk is intended to encourage that if you want to learn this stuff, great place to start. Yes, sir?
Can you talk more about that overhead thing that you just
The overhead? Well, it works basically the way any any planner node works, but there is a special interface of foreign data wrappers as opposed to generic planner nodes, and there is some overhead in doing the transformations and things like that. It's not huge, to be clear. For example, as an experiment, I wrote a foreign data wrapper that there was a table of floats. That, you know, what it looked like to the user is it was an infinitely long table, essentially infinitely long table of floats, which was random numbers. It was basically a random number source as a foreign data wrapper. It was pretty fast, you know. It's because it is using the internal mechanism for handing up things like that. So I would not shy away from writing a foreign data wrapper just because of the performance. Specifically, if you're querying a remote source outside the server, the overhead of the foreign data wrapper is not where the overhead is going to be. The network round trip time, and I think, will swamp the internal overhead. Yeah. Excellent question. Anything else? Okay. Thank you very much.